We have a monotone likelihood ratio for an exponential distribution, and if that ratio is increasing or decreasing. So I've selected two parameters, theta 1 and theta 2, where theta 1 is less than theta 2. They're both in my parameter space. Then I need to look at the ratio. So it is the likelihood where the bigger parameter is in the numerator or the upstairs, and the smaller parameter is in the denominator or the downstairs. Since I have lots of data values, I have to take the product of their densities. And the same thing is on the denominator. Using some exponent rules and some algebra, I get theta 2 over theta 1 times n e to the power of negative theta 2 y, which is the sum of my x's, e to the power of negative theta 1 y. Now, I want to check if I have monotone likelihood ratio for a statistic of the data. My statistic for the data is going to be this y term. And if that's the case, well, this first term over here has nothing to do with y. So this is the same thing as just checking this quantity over here and not paying attention to that quantity because there's nothing to do with y. So I'm going to use proportional to and do a little bit more rearrangement. Theta 1 minus theta 2 y. And then once more rearrangement, I have e to the power of theta 1 minus theta 2 all to the power of y using exponent rules. So now I definitely have a monotone likelihood ratio as a function of y, but I'm not quite sure if it's increasing or decreasing. It depends on what this quantity is over here to the power of. This is just a constant in our situation, and a constant times the power of y, and if y is getting bigger and bigger, this value is either getting bigger or bigger or smaller and smaller, depending on whether or not what's inside of our square brackets is less than or equal to 1. So we'll go ahead and check, is it increasing or is it decreasing? Now, some of you may be able to tell this right away, but it's sometimes easy just to do a quick, slow down a little bit and do a quick gut check. I'm specifically going to check if it's decreasing. If it's decreasing, then this value inside of the square brackets would be theta 1 minus theta 2 would be less than 1. And I don't know if this is the case, so I'm going to put a little question mark. This is what I'm checking. I take the log of both sides and I get theta 1, the natural log, less than 0. And we see simple rearrangement. Yes, this is in fact 2, so we have a decreasing monotone likelihood ratio as a function of y. Now, this is great for us, but one of the things I want to note is that we could have just as easily set this problem up another way. It's one of the interesting things about monotone likelihood ratios. So what if instead I had a statistic, and I'm going to let t equal negative y. Well, then my likelihood function, theta 2 over x, L theta 1 over x, is proportional to e to the power of negative theta 1 minus theta 2 times minus y. So I just multiplied it by negative 1 times negative 1. This is equal to e theta 2 minus theta 1. Jumping ahead of myself, times t which is equal to e to the power of theta 2 minus theta 1, all to the power of t. Now we could see with this other alternative statistic that we have an increasing monotone likelihood ratio as a function of t. And I figured out it was an increasing monotone likelihood ratio as a function of t because of this check that we did over here. So in any situation, we can often find versions of the monotone likelihood ratio and a statistic of the data in which it is increasing or decreasing, which will be helpful for us later on.